Fine-tuning is less about adding facts and more about teaching behavior. The examples you prepare, prompts, responses, context, and style become the signals the model learns from. Better data leads to clearer, more reliable responses. So far, we've built the core path: how ML and LLMs use context, how RAG adds external knowledge, and where fine-tuning fits. Now we shift to the ingredient fine-tuning depends on most: high-quality examples. Fine-tuning data is a set of demonstrations, not a document archive. Each example shows the model. When the user asks this, use this context, follow this style, and answer in this format. Across many examples, the model adjusts toward those repeated patterns. That is powerful, but it also carries risk. If the dataset contains inconsistent tone, weak reasoning, or bad completions, the model can learn those habits too. That's why data preparation often matters more than the training run itself. Raw text may contain useful information, but it does not clearly show the model what to do when a user asks something. Structured examples pair an input with the desired response, so the model learns behavior, tone, format, steps, and decision patterns. If the issue is changing facts or fresh knowledge, use retrieval instead. Fine-tuning is for shaping how the model responds. In a basic fine-tuning record, a realistic user request is paired with the answer you wish the model had given. The instruction should sound like something a real user would ask, not like a synthetic label. The response is the teaching signal. Its tone, structure, accuracy, and level of detail become the behavior the model learns to imitate. When many examples follow the same pattern, the model can generalize that pattern to new requests. Chat fine-tuning data is often stored as a conversation, not just a single prompt and answer. Each message has a role. The system role sets durable behavior, such as tone, safety boundaries, or level of detail. The user role provides the request. The assistant role shows the response we want the model to imitate. Multi-turn examples add another signal: how to carry context forward, answer follow-ups, and stay consistent across an exchange. A useful way to think about fine-tuning is practice drills. The model is not trying to memorize every drill. It is learning what good performance usually looks like. When patterns repeat across realistic examples, they become tendencies the model can reuse. Varied phrasing helps too. If users ask for the same task in different ways, the model learns flexibility. But if examples are too narrow, it may only succeed in those exact situations and fail when the request changes. Fine-tuning can also teach a model to treat prompt details as evidence, not background noise. If examples repeatedly use the customer tier, policy excerpt, and claim amount in the answer, the model learns that those details matter. The result is fewer generic replies and more grounded responses. But the boundary still matters. Fine-tuning shapes behavior. It still needs retrieval for current facts. Beyond content, fine-tuning can teach how answers should look and sound. If every example uses the same headings, JSON fields, bullet style, length, and tone, the model starts treating that pattern as expected behavior. Consistency is the key. Mixed formats, shifting field names, or changing levels of formality blur the signal. Your training set should model the exact template and voice you want repeated in production. Coverage means building a bridge between what users usually ask and what they might ask under messy real conditions. Don't train only on clean, repeated examples. Include routine requests, ambiguous phrasing, long context, formatting constraints, and cases where the right answer is a refusal. Also check balance across workflows. If one task dominates, the model may become excellent there, but brittle everywhere else. Coverage is intentional planning, not random collection. Before fine-tuning, treat your dataset like source code. Clean it before you trust it. Remove duplicates, incomplete rows, and examples that contradict each other. Use one label scheme, one format, and consistent terminology, so the model is not guessing what you mean. Then fix factual or grammatical errors and verify that each response actually follows the instruction. Clean data sharpens the training signal and reduces strange behavior later. Fine-tuning does not just teach capability. It also teaches patterns of judgment. If examples contain biased wording, weak labels, stereotypes, or missing scenarios, the model may reproduce those patterns at scale. The result can be uneven quality for different users or use cases. Dataset review is not a cosmetic step. Check who is represented, how they are described, and where assumptions appear. Balanced, realistic examples help the model behave more fairly and more reliably. To evaluate fine-tuning honestly, do not train on every example you have. Set aside separate groups before training begins. The training set teaches the target behavior. The validation set helps you adjust settings and catch problems while you iterate. The test set stays untouched until the end, giving you a final quality check. A common starting split is 80, 10, 10. But the real priority is that each set contains realistic examples that match future user requests. Fine-tuning data is not a one-time cleanup task. After training, look closely at where the model fails. Those failures show what the dataset is missing, which instructions are ambiguous, and which examples may be teaching the wrong behavior. Add examples for repeated mistakes and edge cases. Remove or rewrite bad examples. Then retrain and evaluate again. Each loop brings the dataset closer to the behavior you actually want. Remember, fine-tuning data is behavioral training, not a knowledge dump. Strong examples show the instruction, the context to use, the format to produce, and the style to follow. When those examples are clean and representative, the model becomes more reliable. Next, we'll choose between prompting, RAG, ML, and fine-tuning.